National Electrical Code, Article 411.3, states that for lighting luminaires rated less than 1000 volts, not more than 12 conductors shall occupy the same cable or raceway. The bell wire used for the puck lights is 18/2, which means it has 2 conductors. There are 22 puck lights installed, each with an individual home run of bell wire to the transformer. This results in a total of 44 conductors, that is 22 multiplied by 2, occupying the single cable or raceway, the bell wire. According to Article 411.3, no more than 12 conductors are allowed in the same cable or raceway for lighting luminaires rated less than 1000 volts. Overcrowding conductors in a cable or raceway can lead to overheating, which can cause insulation damage, fires, and electrical hazards. To rectify the code violation and ensure the safe and proper operation of the puck lights, firstly, remove the existing bell wire home runs. Secondly, install new 12 American wire gauge low voltage cables to connect each puck light to the transformer. Thirdly, use cable ties or other approved methods to secure the cables neatly. Electrical codes exist to protect people and property from hazards arising from the use of electricity. Ignoring these regulations can have serious consequences, potentially leading to fires, injuries, or even fatalities. Understanding the National Electrical Code, often referred to as the NEC, is crucial for anyone involved in electrical work, including electricians, contractors, and even homeowners undertaking DIY projects. The NEC provides detailed guidelines and requirements for safe electrical installations, covering everything from wiring methods and overcurrent protection to grounding and equipment installation. Article 411 specifically addresses lighting systems operating at low voltage, typically below 30 volts alternating current or 60 volts direct current. These systems are commonly used for landscape lighting, accent lighting, and, as in this case, under-cabinet lighting. The NEC sets limitations on the number of conductors allowed within a single cable or raceway to prevent overheating and ensure safe operation. When multiple conductors are bundled together, they generate heat. If the heat cannot dissipate effectively, the insulation surrounding the conductors can degrade, leading to short circuits, ground faults, and potentially fires. The NEC conductor fill requirements are designed to prevent this overheating by limiting the number of conductors in a confined space. In this situation, the use of 18/2 bell wire for individual home runs to each of the 22 puck lights created a significant code violation. Each 18/2 cable contains 2 conductors, a positive and a negative. With 22 puck lights, this resulted in a total of 44 conductors being crammed into the same cable or raceway, far exceeding the 12 conductor limit specified in Article 411.3. The excessive number of conductors would have undoubtedly led to overheating within the bell wire bundles. The heat generated by the current flowing through the conductors would have been trapped, potentially causing the insulation to melt or break down over time. This could have created a dangerous situation, increasing the risk of electrical shorts and fires. Furthermore, the use of undersized wire, such as 18 American wire gauge bell wire, for low voltage lighting applications can further exacerbate the problem. Smaller gauge wires have a higher resistance, which means they generate more heat for a given amount of current. This increased heat, combined with the overcrowded conductors, creates a double whammy effect, significantly increasing the risk of electrical hazards. To rectify this code violation and ensure a safe and compliant installation, the existing bell wire home runs must be removed and replaced with appropriately sized low voltage cables. The recommendation to use 12 American wire gauge wire is a good starting point, but it's essential to consider the specific requirements of the lighting system and the length of the wire runs. Longer wire runs require larger gauge wires to minimize voltage drop and ensure that the lights receive the proper voltage. Voltage drop occurs when the voltage at the end of a wire run is lower than the voltage at the source. This can cause the lights to dim or flicker, and it can also damage the transformer. The amount of voltage drop depends on the wire gauge, the length of the wire run, and the amount of current flowing through the wire. There are voltage drop calculators available online that can help you determine the appropriate wire gauge for your specific application. In addition to using the correct wire gauge, it's also important to use cable ties or other approved methods to secure the cables neatly. This will help to prevent the cables from becoming tangled or damaged, and it will also improve the overall appearance of the installation. When running the new cables, be sure to follow all applicable electrical codes and regulations. This includes using proper wiring methods, ensuring adequate overcurrent protection, and grounding the system properly. Overcurrent protection devices, such as fuses and circuit breakers, are designed to protect the electrical system from overloads and short circuits. They are essential for preventing fires and other electrical hazards. Grounding the electrical system provides a path for fault current to flow back to the source, which helps to trip the overcurrent protection device and to energize the circuit. This can prevent electric shock and other injuries. It is imperative that only qualified electricians perform electrical work. They have the knowledge, skills, and experience to ensure that the installation is safe and compliant. Attempting to perform electrical work without the proper training can be dangerous and can result in serious injury or death. Moreover, improper electrical work can void your homeowner's insurance policy, leaving you financially responsible for any damages caused by electrical fires or other hazards. When hiring an electrician, be sure to check their credentials and ensure that they are licensed and insured. A licensed electrician has met the requirements set by the state or local government to perform electrical work. They have passed an examination and have demonstrated their knowledge of electrical codes and safety practices. Insured electricians have liability insurance, which protects you in case they cause any damage to your property while performing electrical work. In summary, the use of bell wire for individual home runs to low-voltage puck lights is a code violation that can create a dangerous situation. To rectify this violation, remove the existing bell wire and replace it with appropriately sized low-voltage cables, ensuring to follow all applicable electrical codes and regulations. Always consult with a qualified electrician to ensure the safety and compliance of your electrical system. The National Electrical Code is regularly updated to reflect the latest advancements in electrical technology and safety practices. It's important to stay informed about the latest code changes to ensure that your electrical installations are up to date and compliant. There are several resources available to help you stay informed about the NEC, including the National Fire Protection Association, which publishes the NEC, and various electrical trade organizations. Attending continuing education courses and workshops can also help you stay up to date on the latest code changes and best practices. Remember that electrical safety is paramount. Taking the time to understand and comply with electrical codes and regulations can help to prevent fires, injuries, and other hazards. Always prioritize safety when working with electricity, and never hesitate to consult with a qualified electrician if you have any questions or concerns. Regularly inspect your electrical system for any signs of damage or wear and tear. This includes checking for frayed wires, loose connections, and cracked or broken outlets and switches. If you notice any problems, have them repaired immediately by a qualified electrician. Consider installing arc fault circuit interrupters, also known as ASIs, in your home. ASIs are a type of circuit breaker that can detect arc faults, which are a common cause of electrical fires. ASIs can help to protect your home and family from electrical hazards by tripping the circuit breaker when an arc fault is detected. Avoid overloading electrical circuits. Overloading a circuit can cause the wires to overheat and potentially start a fire. To avoid overloading a circuit, do not plug too many appliances or devices into the same outlet or circuit. If you are unsure whether a circuit is overloaded, consult with a qualified electrician. Use extension cords safely. Extension cords should only be used temporarily and should never be used as a substitute for permanent wiring. When using an extension cord, be sure to choose one that is rated for the amount of current that you will be drawing. Do not overload extension cords and do not run them under rugs or furniture, as this can cause them to overheat. Keep electrical appliances away from water. Water is a good conductor of electricity, so it is important to keep electrical appliances away from water to prevent electric shock. Never use electrical appliances in the bathtub or shower, and do not touch electrical appliances with wet hands. Teach children about electrical safety. Children should be taught about the dangers of electricity and how to use electrical appliances safely. They should also be taught not to play with electrical outlets or cords. By following these simple safety tips, you can help to protect yourself and your family from electrical hazards.